This is SpaceTime Series 28, Episode 56, for broadcast on the 9th of May 2025. Coming up on SpaceTime, a stunning new map of the nearby Milky Way galaxy, searching for the dark in Martian light, and NASA investigating problems with the Psyche spacecraft's thruster system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's New Horizons spacecraft has provided astronomers with an important new ultraviolet map of our galaxy, the Milky Way. The spectacular new observations reported in the Astronomical Journal use a specific ultraviolet wavelength, shedding new light on structures and processes in the galactic regions surrounding our solar system. In fact, these new landmark observations are providing astronomers with their first clear view of the sky surrounding the solar system at these wavelengths, and they're revealing both new characteristics of that sky and refuting old ideas. The study's lead author, Randy Gladstone from the Southwest Research Institute, says the new findings are showing hot interstellar gas bubbles like the one our solar system's embedded within may actually be regions of enhanced hydrogen gas emissions at wavelengths known as Lyman alpha. Lyman alpha is a specific wavelength of ultraviolet light emitted and scattered by hydrogen atoms. It's especially useful to astronomers studying distant stars, galaxies, and the interstellar medium, as it can help detect the composition, temperature, and movement of these distant objects. During its initial journey to Pluto, New Horizons collected baseline data about Lyman alpha emissions using its ALICE ultraviolet spectrograph. Spectrographs split light into various wavelengths or colours, and ALICE specialises in the far ultraviolet wavelength band. After the spacecraft's primary flyby of the dwarf planet Pluto and its binary partner Charon, scientists used ALICE to make broader and more frequent surveys of Lyman alpha emissions as New Horizons travelled further from the Sun. These surveys included an extensive set of scans mapping roughly 83% of the sky. To isolate emissions from the galaxy, astronomers modelled scattered solar Lyman alpha emissions and then subtracted them from the spectrograph's data. The results indicate a roughly uniform background Lyman alpha sky brightness 10 times stronger than what was expected from previous estimates. Gladstone says the results point to the emission and scattering of Lyman alpha photons by hydrogen atoms in the shell of a hot bubble known to surround our solar system and nearby stars. That bubble was formed by nearby supernova events millions of years ago. The study also found no evidence that a hydrogen wall thought to surround the Sun's heliosphere substantially contributes to the observed Lyman alpha signal. Astronomers had theorized that a wall of interstellar hydrogen atoms would accumulate as they encountered the edge of the heliosphere, the vast region of space encapsulating our solar system dominated by the solar wind. However, the New Horizons data saw nothing to indicate the wall is an important source of Lyman alpha emissions. This is SpaceTime. Still to come, searching for the dark in the Martian light, and NASA mission managers are investigating a major problem with the electric propulsion system aboard its Psyche spacecraft. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by NordVPN, our official VPN partners and the ones we trust right here on the show. These days, it doesn't take a hacker in a dark room to compromise your online safety. In fact, every time you connect to a public Wi-Fi, at a cafe, an airport, or even a hotel, your data could be exposed. Passwords, email, and even your personal information is all vulnerable. And that's where NordVPN comes in. NordVPN protects you with world-class encryption, keeping your online activities private and your data safe from prying eyes, no matter where you are. Plus, with NordVPN, you can stream your favorite programs securely, access content globally, and even avoid annoying bandwidth throttling. And right now, we have an exclusive deal for SpaceTime listeners, up to 74% off your NordVPN plan, plus 4 extra months free. And it all comes with a 30-day money-back guarantee. So, protect your data and protect your freedom. Just head to nordvpn.com/Stuart Gary. That's nordvpn.com/Stuart Gary. Or use the code name Stuart Gary at the checkout. Your gateway to a safer, freer internet with NordVPN. And now, it's back to our show. NASA's Mars Perseverance Rover has been busy over the past week, continuing its exploration of the lower Witch Hazel Hill outcrop exposed on the edge of the Jezero crater rim. The formation is composed of alternating light and dark layers of rock, and mission managers have been busy trying to understand the makeup and relationship of these layers. A few weeks ago, they sampled one of the light tone layers at a place they've named Main River. They discovered it was made up of very small clasts or fragments of rocks and minerals. Since then, scientists have learned that the darker layers tend to be composed of larger clasts compared to the lighter layers, and they've been searching for a place to sample this coarser-grained rock type. Sometimes these coarser-grained rocks also contain spherules, which are of great interest to scientists because they provide clues about the very processes that form the layered rock formations in the first place. Perseverance first looked at a dark layer at Punch-On Rock using its abrasion tool. They then examined another dark layer at a formation known as Wreck Apple, but couldn't find a suitable space to abrade. So, while scientists searched for other locations to study the coarse-grained units and spherules, Perseverance drove further south to a place known as Port Anson. Port Anson's intriguing because from orbit it showed a clear contact between the lighter layers of Witch Hazel Hill and a distinct unit below it. And although the rocks below the Port Anson contact point do show interesting compositional differences with those of Witch Hazel Hill, they weren't the coarse-grained rocks scientists were looking for. Still, they did perform an abrasion test there at a location they've named Strong Island, before driving back up north for what hopefully will be another attempt at investigating the coarser-grained rocks. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, NASA mission managers investigating a serious problem with the electric propulsion system aboard its Psyche spacecraft. And we explore the constellation Scorpius, the spectacular M6 and M7 open star clusters, and the Eta Aquarids meteor shower produced by Halley's Comet in the May edition of Skywatch. NASA mission managers are investigating a problem with the electric propulsion system aboard the Psyche spacecraft. Launched on a Falcon Heavy rocket back in October 2023, the 2,608-kilogram probe is on a mission to explore the metallic main belt asteroid 16 Psyche in order to learn more about the origins of planetary cores. 16 Psyche is the heaviest known M-type asteroid, and it may be the exposed iron core of a protoplanet, the remnant of a violent collision with another object that stripped this body of its mantle and crust. The spacecraft will eventually spend 817 Earth days orbiting the strange 226-kilometre-wide metallic world. But it's got to get there first. Mission managers with NASA's Jet Propulsion Laboratory in Pasadena, California, say the spacecraft's electric thrusters shut down on April the 1st when pressure fell in the line that feeds Xeon propellant to the Hall effect thrusters. The pressure dropped from 248 kilopascals down to 179, causing the thrusters to stop working. The probe turned on its Hall effect thrusters in May 2024, which combined with a gravity-assist Mars flyby scheduled for May next year will allow the probe to arrive at Psyche in August 2029. Now, right now, there's not too much to worry about. Psyche can continue to coast until the middle of June before there's a significant effect on its trajectory. Right now, potential solutions include switching to a backup propellant line. It's the first major problem with the spacecraft, which has been working nominally since its long-delayed launch. See, the project had suffered a series of development problems during its construction phase. These included the COVID pandemic and software testing delays, which pushed back the launch date from the originally slated August 2022 by more than a year. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for the month of May on Skywatch. May is the 5th month of the year in both the Julian and Gregorian calendars. The month was named for the Greek goddess Maya, who was identified with the Roman-era goddess of fertility Bonadia, whose festival was held in May. But I guess more importantly for many of our listeners, May typically marks the start of summer vacation season in the United States and Canada. Let's start our tour of the night skies by looking east, where you'll see the constellation Scorpius the Scorpion. In Greek mythology, the constellation was named after Scorpius, who was sent to Earth by the goddess Gaia in order to slay Orion the Hunter, after he boasted that he could kill all the animals on Earth. Scorpius stung Orion in the shoulder, but Orion's life was spared by Ophiuchus the Healer, and it was placed in the heavens along with Scorpius, who continues to pursue him for eternity. Orion the Hunter has become the hunted forever, with Scorpius rising in the east this time of year to triumphantly chase and defeat Orion, who sets in the west. Meanwhile, Ophiuchus the Healer rises in the east following behind Scorpius to chase and crush him into the earth as the Scorpion sets in the west. And so, this ancient story continues to play out in the heavens year after year. Interestingly, parts of this story predate the Greeks, with Orion known in ancient Egypt as Osiris, the god of the underworld and of regeneration. The brightest star in Scorpius is Alpha Scorpii or Antares, the scorpion's heart. In ancient Greek, the name Antares means the equal or rival of Mars, the god of war. That's because its golden orange appearance is similar to that of the red planet, and it passes very close to Mars every 780 years. Easily seen with the unaided eye, Antares is some 550 light-years away. But it looks so bright because it's around 57,500 times as luminous as the Sun, and is one of the largest known stars in the universe. Antares is a red supergiant, about 18 times the mass and 883 times the diameter of the Sun. Were it placed where the Sun is in our solar system, it would engulf all the terrestrial planets, Mercury, Venus, Earth and Mars, and its visible surface would extend almost as far out as Jupiter. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Astronomers believe Antares began life around 12 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red stars. Each spectral classification system can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So put it all together and you can describe our Sun as being a G2V or G25 yellow dwarf star, one of millions spread across our galaxy. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Like the similar-sized red giant Betelgeuse in the constellation Orion, Antares will almost certainly end its life as a spectacular Type 2 or core collapse supernova, probably sometime within the next 100,000 years or so. When it does explode, it'll appear as bright as the full moon for several months on end, and will be clearly visible during daylight hours here on Earth. Antares has a companion star, Antares B, located between 224 and 529 astronomical units away from the primary. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometres or 8.3 light minutes. Spectral analysis of Antares B indicates it's pulling a lot of material off its bloated red supergiant companion. Located near Antares is the M4 globular cluster. Globular clusters are tight balls densely packed with thousands to millions of stars, which were either all originally formed at the same time from the collapse of the same molecular gas and dust cloud, or alternatively they're galactic centres, the remains of ancient galaxies that have been merged into the Milky Way galaxy over billions of years. M4 is composed of 1 million or so stars originally born some 12 billion years ago. The M4 globular cluster is located some 7,200 light-years away, making it one of the nearest globular clusters to Earth. Easily seen through a pair of small binoculars, it covers an area of the sky as seen from Earth as big as the full moon. Astronomers estimate there are some 150 or so globular clusters orbiting in the halo of the Milky Way. Located near the tail of the Scorpion are two open star clusters known as M6 and M7. Open star clusters are loosely bound groups of a few thousand stars, which all originally formed from the same molecular gas and dust cloud at the same time, but are not as densely bound as globular clusters. Open clusters generally survive for a few 100 million years, with the most massive ones surviving for maybe a few billion years. Now, in contrast, the far more massive globular clusters exert far stronger gravitational attraction on their members, which is why they can survive so much longer. M6, which is also known as the butterfly cluster, is some 12 light-years across and located about 1,600 light-years away. It contains around 80 stars, which are all less than 100 million years old, which is quite young in cosmic terms. The M7 or Ptolemy cluster is named after the famous Greek astronomer and mathematician Claudius Ptolemy. It's about 980 light-years away and is far more dispersed than M6, covering an area around 25 light-years across. And at around 200 million years, it's about twice as old. By the way, the M in terms like M4, M6 and M7 are abbreviations for Messier, in honour of the 18th century French astronomer Charles Messier, who developed an astronomical catalogue of fuzzy nebulous objects in the skies. See, Messier was a comet hunter, and he compiled a list of 103 fuzzy objects which weren't comets, and so from his perspective could be ignored. Later, other astronomers added additional celestial objects to the list, bringing the present catalogue up to 110. Our solar system, in fact most of the stars we see when we look up in the night sky, are located in the Milky Way galaxy's Orion Arm. The Orion Arm, also known as the Orion Spur or the Orion Cygnus Arm, depending on which name you prefer, is some 3,500 light-years wide and around 10,000 light-years long. The Orion Arm is named after the Orion constellation, which is one of the most prominent constellations in the Southern Hemisphere summer and Northern Hemisphere winter. Some of the brightest and most famous celestial objects in the constellation include Betelgeuse, Rigel, the stars of the Orion Belt, and the Orion Nebula, all located within the Orion Arm. The Orion Arm is located between the Carina-Sagittarius Arm, which is more towards the galactic centre from our position, and the Perseus Arm, which is more towards the outer edge of the galaxy from our point of view. The Perseus Arm is one of the two major arms of the Milky Way, the other being the Scutum Centaurus Arm. Long thought of as a minor structure, a spur if you will, between the two longer adjacent arms, Perseus and Carina-Sagittarius, evidence was presented in mid-2013 that the Orion Arm might actually be a branch of the Perseus Arm, or possibly a completely independent arm segment itself. Within the Orion Arm, our solar system, the Sun, the Earth and all the other planets we know, are located close to the inner rim in what's known as the local bubble, about halfway along the Orion Arm's length, approximately 26,000 light-years from the galactic centre. The local bubble is a cavity in the interstellar medium in the Orion Arm, containing among other things the local interstellar cloud which contains our solar system, and the G-cloud. It's at least 300 light-years across, and it has a neutral hydrogen density of just 0.05 atoms per cubic centimetre. That's just 1/10 of the average for the interstellar medium across the Milky Way, and about a sixth that of the local interstellar cloud. The hot diffuse gas in the local bubble emits X-rays and is the result of a supernova that exploded sometime during the past 10 to 20 million years. It was once thought that the most likely candidate for the remains of this supernova was Geminga, a pulsar in the constellation Gemini. However, later it was suggested that multiple supernovae in a subgroup B1 of the Pleiades moving group was more likely responsible, becoming a remnant supershell. Our solar system has been travelling through this region of space occupied by the local bubble for the last 5 to 10 million years. Its current location is in what's known as the local interstellar cloud, a minor region of slightly denser material within the bubble. The cloud formed when the local bubble and another bubble called the Loop 1 bubble met. Gas within the local interstellar cloud has a density of about 0.3 atoms per cubic centimetre. From what we can tell, the local bubble isn't spherical, but seems to be narrower in the galactic plane, becoming somewhat egg-shaped or elliptical, and may even become wider above and below the galactic plane, becoming shaped more like an hourglass. And it's not alone, it's abutting other bubbles of lesser dense interstellar medium, including the Loop 1 bubble. The Loop 1 bubble was created by supernovae and stellar winds in the Scorpius-Centaurus Association some 500 light-years from the Sun. The Loop 1 bubble also contains the star Antares that we spoke about earlier. Astronomers have identified several, well, I guess you'd call them tunnels, which connect the cavities of the local bubble with that of the Loop 1 bubble. Collectively, they've been referred to as the Lupus Tunnel. Other bubbles which are adjacent to our local bubble are known as the Loop 2 bubble and the Loop 3 bubble. Looks like astronomers still have a problem when it comes to thinking up cool names. Also visible this month is the Eta Aquarids meteor shower, which is generated as the Earth passes through the dust and debris trail left behind by Halley's Comet. Comet P1 Halley's a well-known short-period comet which visits the inner solar system every 75 to 76 years. The 15-kilometre wide mountain of rock and ice will make its next close-up appearance in 2061. It's named in honour of the British astronomer Edmund Halley, who in 1705, after examining ancient Chinese, Babylonian and medieval European records, successfully predicted its return in 1758. However, he died in 1742, before his prediction could be confirmed. The comet's highly elliptical and elongated orbit takes it from between the orbits of Mercury and Venus out almost as far as the orbit of Pluto. Halley's orbit is in retrograde, meaning it orbits the Sun in the opposite direction to the planets, that is, clockwise from above the Sun's northern pole. This retrograde orbit results in it having one of the highest velocities relative to the Earth of any object in the solar system, travelling at some 70.56 kilometres per second, or if you prefer, 254,016 kilometres per hour. As well as the Eta Aquarids meteor shower every May, Halley's Comet also produces the Orionids meteor shower in late October. Astronomers think Comet Halley was originally a long-period comet which took thousands of years to travel to the inner solar system from the Oort cloud, but was gravitationally perturbed into its current orbit by close encounters with the giant outer planets. The Oort cloud is a hypothetical sphere of comets and asteroids beyond the heliosphere, a mixture of vagabonds from the solar system and objects from deep space which have been collected by the Sun's gravitational pull. Occasionally, as the Sun passes by another star, an Oort cloud object will get perturbed and be flung towards the inner solar system. The Eta Aquarids meteor shower runs from the 19th of April through to the 28th of May, peaking around May the 5th, with around 55 meteors an hour, making it one of the Southern Hemisphere's best celestial showers. However, back in 1975, they were running 95 meteors an hour, and in 1980 it was up to 110. Even better, the bright yellow meteors often appear as streaks known as trains. As their name suggests, they radiate out from the direction of the constellation Aquarius and the star Eta Aquarii. Just look towards the east after midnight and before dawn for the best view. And joining us now for the rest of our tour of the May night skies and Skywatch is science writer Jonathan Nally.
G'day, Stuart. Yes, it's May, so the nights are definitely getting longer and colder in the part of the planet where I live as we head towards winter. But, despite the cold, this is actually a great time for stargazing if you live where I am in the southern hemisphere, as there are lots of great southern-only constellations visible. So some of the ones that, you've got to be far south to see, such as the Southern Cross, which at the moment is standing pretty much upright, high in the south in the middle part of the evening. To its left, we've got these two bright stars in the constellation Centaurus. That's Alpha and Beta Centauri. And astronomers call them the two pointers because if you draw an imaginary line between them and then keep the line going, it more or less points towards the Southern Cross. Those two stars are really quite bright and prominent and they're close together, so people often spot them before they spot the Southern Cross.
Yeah, I was using them as a marker to help me find the Southern Cross.
Yeah, and look, they're very bright compared to the stars. The stars in the Southern Cross are not particularly dim, but it's a small constellation, and when people go out try to find the Southern Cross, they're looking for something bigger, so they don't really notice the cross at first. So if you find these two pointer stars and then you just do this trick of drawing the line and extending it a bit, then you think, oh, that's the Southern Cross, is it? So they're quite handy. Now, in the vicinity of the cross, there are two interesting sights to see, although you probably do need some non-shitty dark skies to get a good view of them. The first of them is what's called the Coal Shack Nebula, which is a dark patch in the Milky Way right next to the Southern Cross. It's quite large. It's probably about half the size or more of the Southern Cross. It's quite large, actually. It's a huge cloud of gas and dust, almost 600 light years away, and because it's a very thick cloud of gas and dust, it's blocking out the light of the stars behind it. So, years and years and years ago, before photography started to come along, astronomers weren't really sure, was this a hole in the Milky Way and we're looking straight through out to the other side? Or is this a big dark something that's blocking the light from the stars behind? And yes, it is a big dark blob that is blocking the light of the stars behind it. There are stars in front of it too, but not too many. They're not very obvious to the naked eye. But you probably do need dark stars to see the Coalsack Nebula. I struggle to see it from where I am in suburbia. The other object of interest is a small star cluster called the Jewel Box, which is located a bit below and to the left of the leftmost star in the Southern Cross. Now, if you live in the city, you might just be able to make it out with your own eyes, but a pair of binoculars will definitely help. And through them, you'll see a pretty collection, maybe half a dozen, 7 or 8, 10 stars perhaps, of different colours. That's why it's called the Jewel Box. And they're all closely packed together. All up, there are actually about 100 stars in this cluster, but you're not going to see all of those with a pair of binoculars. You need a big telescope to start to see dozens and dozens of them. But it is really, really pretty, and it's quite an easy one to see, and it's fairly bright as star clusters go. That's much further away than the Coalsack. Coalsack's about 600 light years away. This little Jewel Box cluster is 6,500 light years away. Now, to the right of the Southern Cross, as we look down to the south, you've got 3 large constellations. You've got Carina, Vela, and Puppis, all part of the Milky Way, and they're full of glorious star fields and lots of nebulae and things, including one called the Great Nebula in Carina. Now, this one rivals, or in some people's opinions, it even exceeds the splendour of the more famous nebula, the Orion Nebula, which is very easy to make out. Because you need to be down south here to see the Carina Nebula. You've got to be down south, and it is a large fuzzy patch which you can see with your own eyes if you're under dark skies. But if you can get a telescope onto this region, it just lets you see so much more. It really is quite spectacular. The extent of it, if you were able to see the whole thing with your own eyes, it would be several times the width of the full moon. It's very large in the night sky. We don't notice it normally because it is fuzzy and faint, and most of us live in light-polluted cities, so you've got Buckley's chance, as we say in Australia, of seeing anything like this from light-polluted skies, so you need to get somewhere dark and let your eyes get dark adapted. Now, in the nearby constellation, same sort of, the other side of the cross really, you've got Centaurus. You can find the globular star cluster Omega Centauri. Now, this one is quite easy to see. It's visible as what looks like a fuzzy star to the unaided eye. You've got a pair of binoculars. You'll reveal it, depending on the size of your binoculars, it should reveal it to be like a small grey ball, just a tiny grey ball. But a telescope will show its true nature, which is a huge globe of seemingly countless stars, a globular star cluster it's called. It's a really impressive sight. And if you get on the internet and have a look for Omega Centauri, you'll see what I mean. It is the most, in fact, it's the best of these globular star clusters in the whole sky. It's the biggest and best and brightest. It really is very, very impressive. Now, low down in the eastern sky at mid-evening, you've got the constellation Scorpius above the horizon. This, for me, is a true indication that the middle of the year is upon us, because Scorpius is, us in the southern hemisphere, a winter constellation. For our friends in the north, it's a summer constellation. So as the evening goes on, the full extent of Scorpius will come up and be visible. Scorpius is one of the rare constellations that actually looks like what it's supposed to be. You've got the constellation Triangulum, which is a triangle, right? So that's not too hard. The Southern Cross does look like a Southern Cross, but Scorpius really does look like a scorpion. It traces out the shape of the scorpion really, really well. It's just one of those things. We just happen to be in the right part of the galaxy to see these stars from this point of view, and it really does. The constellation right next to it, famous Sagittarius, got no idea what that looks like. It's one of the join the dot things. But when we do look at Sagittarius, which we will see if you stay up past midnight, you'll see Sagittarius come up, or if you wait for a month or two, it'll be in the evening sky. When we look towards Sagittarius, we are looking into the direction of the centre of our Milky Way galaxy. And this is actually one of the main reasons why mid-year stargazing is considered so good by amateur astronomers, because we have all the star fields and the deep sky objects of the Milky Way's central region to enjoy. Because we're looking right into the core, there's lots and lots of stuff. If you look in the opposite direction, you're looking towards the outskirts of the galaxy, and there's perhaps less to see. So there's a lot of stuff concentrated in towards the centre of our galaxy during the middle of the year. And because Sagittarius and its sort of surrounding constellations are located south of the celestial equator, it means that those of us who live south of the earthly equator get the best view of it, because from the latitude of where I live, it's basically right overhead at night time. So, when things are right overhead, you're looking through the thinnest part of the Earth's atmosphere. If things are down on the horizon, you're looking through a much greater extent of atmosphere, which makes the stars appear dimmer, and you get twinkling effects and the pollution and dust and whatever in the air. So when you can see things up nice and high, that's a whole lot better. So our friends north of the equator can certainly see Sagittarius and Scorpius as well, but for them it's lower down towards the horizon, and it's still good, but nothing like being right underneath these particular constellations. Now, turning to the planets, Jupiter is big and bright. It's low down near the northwestern horizon after sunset. That's as we view it from the southern hemisphere during May. Now, make sure you take the opportunity to see it in the first 2 or 3 weeks of May, because by the end of the month, it'll have disappeared into the twilight glow down on the northwestern horizon there. It's getting lower each night. Mars is quite easy to see in the northern half of the sky for us here in the south, the southern half of the sky for our friends in the north. It's about halfway up from the horizon. It's in a fairly bare patch of sky, so its intense ruddy colour does make it stand out quite easily amongst all the stars that are around it. Now, the other 3 bright planets are all morning objects at the moment. It's visible out to the east before dawn. First up, we have Venus. It's extremely bright at the moment. You simply cannot miss it or mistake it for anything else. Just if you're up before dawn, look to the east, which is the direction that the sun comes up. And before the sun comes up, you see this big, bright star-looking thing in the sky. Well, that's Venus. There's nothing else like it. Not far from Venus, but quite a bit dimmer, is another bright thing that looks like a star, but it's actually Saturn. And Saturn's fairly easy to spot because it's, compared to other stars, or compared to stars, it's reasonably bright. It's not bright compared to Venus, but it's bright enough. And it does have a yellowish sort of colour to it. About halfway in brightness between Saturn and Venus is Mercury, the planet Mercury, which is the innermost planet. Now, if you want to see Mercury, yes, you've got to be up before dawn, but you also got to get out there and do it now, because as the month goes on, you'll see Venus and Saturn still up fairly high, moving further apart from each other, but Mercury is going to start dropping down toward the horizon night after night. And by the end of the 3rd week of May, it'll be lost in the glare of the dawn glow just before sunrise. So, yeah, if you want to spot Mercury, if you've never seen it before, got to be up before dawn and got to do it in the next few weeks. And that, Stuart, is the sky for May.
That's science writer Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.